now work through quite a few examples of solving square root equations, walking through step by step, and we have to make sure to remember to check for extraneous solutions in each of the equations we are solving, keeping in mind that we could have a result that may not work in our equation. So for starters, whenever you're doing an equation, you want to make sure your square root or your radical is alone on one side with everything underneath it. So we have square root of x minus 3 in this problem, and it's alone by itself, and it's already equal to 4. So now I can basically square both sides. So I'm going to write it as the square root of x minus 3, parentheses squared, and then I have 4 being squared as well. That means that I'm going to have now x minus 3 on the left side, and then a 16 on the right side. And simple enough, I can just add 3 to both sides, giving me an answer of 19. Now, before I go any farther, I want to make sure I'm checking my answer to see if it works out correctly. So in my check that I'm doing here, I'm going to take my 19 for x and substitute it back into the equation. So I have a 19 where the x was, and I want to know if the square root of 19 minus 3 would equal 4, and that means that I would have the square root of 16 equal to 4. So yes, that definitely worked out correctly in our favor here, and we found out that our answer did in fact work. Moving on to our second equation in problem number 2. Number 2, our equation is going to be a little bit different, as we have square root of 2x minus 1. And then I have a plus 5 outside of the radical, and then it's equal to 2. Now, I have a radical, but it's not alone on the side in this equation. And I want to make sure I'm getting rid of that 5 first. So the first thing I want to do is subtract 5 from each side. So I would have the square root of 2x minus 1 is now equal to negative 3. So right away, I can see I have a square root equaling a negative number. So I can kind of predict already that this problem is not going to have a real solution, because our square roots are supposed to equal positive if they're going to be a principal root like we discussed earlier. Now, what I want to do is kind of just keep going through this problem so we can demonstrate what's going to happen later on. So if I'm going to square both sides, I would basically have the square root of 2x minus 1 squared, and then I have negative 3 being squared. That would get rid of my square root and leave me with just 2x minus 1 on the left side, and negative 3 times itself is equal to 9. Now, I can solve this equation for x by adding 1 to both sides first to get 2x equal to 10, and then dividing by 2, I get that x is equal to 5. Now let's check to see if our prediction earlier is actually going to work out and be accurate. So in my check over here to the side, I am going to put my answer of 5 into my original equation where x is, like so. And then I am going to see if this is going to work out the way I think it's going to. So that would mean we would have 10 minus 1 is going to be equal to 9, plus 5 equals 2, or 3 plus 5 would equal 2. And we all know that 8 does not equal 2. So our answer, x equals 5, is not going to work. It is extraneous. And we can write extraneous. We could say no solution for this problem. Kind of means the same thing. And that's kind of what our result of that problem is. Moving on to example number 3, we have kind of the next step up in difficulty for a type of problem in this topic. We have x minus 2 on one side of our equation, and then the square root of 2x minus 4 on the other side of our equation. Now, if I wanted to solve this, I have to make sure I keep in mind that when I'm going to square both sides to get rid of this square root, I got to square both parts of this as one quantity in parentheses. And let's kind of see how that goes now. So I'm going to have the square root of 2x minus 4. I'm going to square that to get rid of my radical symbol. And then I'm going to have x minus 2 squared as a quantity on the left-hand side of my equation. Now, from here, I would multiply out x minus 2 times itself, because that's what our parentheses squared is going to mean. And now that's going to be equal to 2x minus 4. And so when we multiply these two parentheses by each other, I get x squared minus 4x plus 4. And that is going to be equal to 2x minus 4. So now I need to set this equation equal to 0 because I know I have a quadratic equation. And that means I'm going to move 2x and minus 4 over to the left-hand side by subtracting 2x and adding 4 to both sides. The result of that would be x squared minus 6x plus 8 is now equal to 0. Now, when we're at a quadratic, we could have a couple different options. We could use completing the square to solve this. We could use quadratic formula to solve this. We could also try to use factoring to solve this. I am going to be choosing the factoring option in this case because I have a 1x squared, and I know this looks like something that would factor. When I have 1x squared, I'm looking for two numbers that add up to -6 and multiply it to 8. Those two numbers are minus 4 and minus 2. And that means my factored version of this expression is x minus 4 times x minus 2. That means that my two answer possibilities for this equation are 4 and 2. I want to check both of these results to see if both or one or neither of them are going to be extraneous. So let's go and check our answers here. I am going to first put in 4 into my original equation. So it would be 4 minus 2 should be equal to 2 times 4 minus 4. So now that means I have 2 is going to be equal to 2 times 4 minus 4 under here. That's 8 minus 4 is 4. 2 does equal the square root of 4. So check. We know that x equals 4 is not extraneous. Next, we are going to check our answer of 2. So we would have 2 minus 2 on the left side. And we have 2 times 2 minus 4 on the right side. That means we have 0 over here. And then we have the square root of 0 on the right side. And that means that we have square root of 0 equals 0. That is true. So both of them are going to be good answers. They're not going to be extraneous at all. And we can go ahead and accept both of them as answers. Moving to question number 4, we have another radical equal to an expression. And so we're going to approach this kind of similarly to our last problem in that we're going to be squaring both of these sides of this equation and squaring our expression on the right side to go with it. And so we have that result right there. So now we can write as negative 2x plus 30. The square root and square root cancel each other out. And now we have x minus 3 times x minus 3 would eventually give us x squared minus 6x plus 9 as an answer. Once again, we have a quadratic equation to solve. So I'm going to add 2x and subtract 30 from both sides of this equation. That would leave me with 0 being equal to x squared minus 4x plus minus 21. Now, once again, that's an equation we can factor. So I'm going to factor that as for sure. I know that negative 7 plus 3 is equal to negative 4, and negative 7 times 3 is negative 21. meaning the factored version of the right side of this equation would be x minus 7 times x plus 3. Our two answer choices are then 7 and negative 3. And we need to check our answer for both of these. In our check over here to the right, we are going to first put in 7. So the square root of negative 2 times 7 plus 30 should be equal to 7 minus 3. Simplifying the left side, we have negative 2 times 7 is 14. Negative 14 plus 30 is going to be equal to 16. And the right side is equal to 4. We know the square root of 16 does equal 4, so that checks out right. Checking our second answer, x equals negative 3, we have negative 2 times negative 3 plus 30 is now should be equal to 7 minus a negative. It's going, sorry, let's try that again. The square root of negative 2 times negative 3 plus 30 is going to be equal to negative 3 minus 3. So we have 6 plus 30. Positive 6 plus 30 is 36. And then we have negative 3 minus 3 is equal to negative 6. And so that means we would have 6 is equal to negative 6, which is not true. Remember, we're talking about principal roots. We need to talk about the square root of 36 being equal to positive 6. It's principal root. So let's move on to number 5, where we have a different sort of equation happening with radicals. Now we are going to have two radicals, one on each side of our equal sign. And it's going to require a little bit of different steps, but generally speaking, not any more difficult than what we've been working on so far. Since we have a square root expression on both sides of our equal sign and they're alone, we basically can do that first step right away, squaring a radical alone on its own side of an equation. So that means we're going to be squaring this square root of 2x minus 1, and we're going to be squaring the square root of x plus 1. And that means that both of these square roots on either side are going to be disappearing. That's leaving us with 2x minus 1 equal to x plus 1. And now we just have a two-sided linear equation to solve from here. I would solve for x on what's one side. So I'm going to subtract x from both sides and then add 1 to both sides. That is going to leave me with x being equal to 2. Let's check our answer to see if x equals 2 works. Oh, also we forgot to, on number 4, we figured out that negative 3 doesn't work. So you want to definitely remember to cross it out so you don't think that that is a true answer. And that could be very important on a test. So make sure to keep that in mind. So in our check for number 5, we are going to be putting 2 into our equation. So we're going to do square root of 2 times 2 minus 1 is supposed to be equal to the square root of 2 plus 1. And that means we have the square root of 3 being equal to the square root of 3, which is a true statement. And that means that x equals 2 is a true solution and not extraneous. Our problem number 6 is going to be following closely behind problem number 5, where we're going to have square roots on both sides. But in this case, we have a coefficient on the front of both of these square roots. So we have 2 times the square root of x plus 8 is going to be equal to 3 times the square root of x minus 2. And now we could kind of try to get rid of those coefficients of 2 times and 3 times, But the best way to do it is to kind of use our method from number 5. And this will go if only one of these two had that number in front. We could still be doing this. So I'm basically going to just square both sides right away, just like we've been doing in number 5. So I have that squared, and then I have 3 times the square root of x minus 2 squared. And because we have multiplying here, you might remember from exponent rules that the 2, when there's multiple things inside, goes above the 2 things inside separately. That means that we basically would have 2 squared and get 4. And then we have x plus 8 squared, which is going to just be x plus 8 because we squared that square root. And now we are squaring the 3 to get 9. And we are squaring the square root of x minus 2 to just get x minus 2. So kind of a weird step, a little bit weird of an algebra step there, but it's important to notice what happened. We just squared the 2 to get 4. We squared the square root to get rid of it, and then same thing on the right side. Now I'm going to distribute the 4 to x plus 8 and distribute the 9 to x minus 2. So I have 4x plus 32 is now equal to 9x minus 18. And from here, just like with our prior problem, in number 5, we have a two-sided linear equation to solve. So the first thing I would do is subtract 5x from both sides and then add 18 to both sides. That means I have 50 is equal to 5x. From there, I'm just going to divide by 5 so that I have a 10 is equal to x. So let's see if our x equals 10 answer is going to work out in this problem by checking our work. So now in this check, we are trying to see if 10 is going to work in this equation. So I have 2 times the square root of 10 plus 8 should be equal to 3 times the square root of 10 minus 2. Now that at first glance may not look like it would be correct or something that would make sense, but we got to kind of look a little deeper into checking this. So 2 times the square root of 18 should be equal, if this works, to 3 times the square root of 8. So you could put this both in your calculator. Square root of 18 and square root of 8 are both irrational numbers. So you'd have some weird decimals, but your calculator should show that these end up being equal. If you wanted to do it more algebraically, the square root of 18 would actually simplify and become 3 times the square root of 2. And then the square root of 8 would simplify to become 2 times the square root of 2. And then if you do 2 times the 3 on the left side, you get 6 root 2. If you do 3 times the 2 on the right side, you get 6 root 2. And obviously we have found that the two sides equal each other. And that means 10 is a true solution and not extraneous in this number 6 problem. We now are working on problem number 7, and this will be the last example we will cover. We can look at our problem first and see that we have an x squared underneath of our square root. So the square root of x squared plus 1 is sort of a weird equation to look at. I would suggest pulling up desmos.com and pausing the video to take a look at what that sort of function might look like. And then we have the right side is just x plus 1, so that would just be a linear graph, a linear function. And we would be looking to see if they would cross each other. But let's see if we can get into the algebra portion or version of this. Just like with every other example, when we have a radical already by itself, we can square both sides. But make sure you're careful, like if the 1 was on the left side, then make sure that you are going to put the 1 on this side and keep the radical completely by itself. So we're going to square both sides like we've done in all our problems so far when we are at this step. And then we're going to square x plus 1 as its own quantity. Now, when I have squared the left side, I'm going to end up, oh, this is supposed to be a 7. So let's just fix that real quick. x squared plus 7. So we now have that x squared plus 7 is going to be equal to x plus 1 times itself. If you multiply that out, you should get x squared plus 2x plus 1. And then we would look and see, well, we have an x squared on both sides. So you can basically just kind of cancel that out and subtract x squared from both sides. That would mean that we'd be left with 7 being equal to 2x plus 1. And if that's the case, that means that we could subtract 1 from both sides and get 6 is equal to 2x. And then lastly, all we have to do is divide by 2 and get that 3 is equal to x. Let's check to see if that answer works in our original equation. We are going to put in and substitute 3 for x. So we have the square root of 3 squared plus 7 should be equal to 3 plus 1. That means that we have the square root of 9 plus 7 equals 16. And then we have a 4 on the right side. And yes, it does work. And we found out that 3 equals x is a true solution and not extraneous. That covers essentially all the sorts of square root equations that you will see in our course. Hopefully these steps were easy to follow, and I thank you for watching. Have a great day.